Lesson 16 class activities for Math 107 College Algebra. I'm going to skip over this first question that goes through using a graphing calculator or GeoGebra to perform regression. You're not going to be required or tested on what buttons to push to do linear regression. Just know that your calculator or GeoGebra can do it. And the directions are all written out here if you ever want to do regression. So I'm just going to skip through all this, like what button to push stuff, and jump to number 2. Okay, so here is the graph of the regression line that models the number of AFVs in the United States X years after 1995. So I have a picture of the line, I have the equation of the line. R is approximately 0.983, which means it's a very strong positive linear fit. Okay, it's very close to 1, which means it's almost a perfect fit with an increasing line of positive slope. So I want to use that equation to write the y-intercept and explain its significance in context. Okay, I want to explain both coordinates. All right, so my y-intercept is 0, comma, that number. B is always your y-intercept for a line. So this is 216,437.82. Okay, so that means that in 1995, 0 years after 1995, there were approximately, right, because I'm using there were exactly this many ATVs, but my regression line says that there were approximately 216,437.82 AFVs on the road. Okay, the slope of the regression line, and explain its significance. So 35443.28. 35443.28. And remember, slope is a rate of change, so it's always helpful to put an over 1 if it's just a plain old number. And it's change in y over change in x. And your y units are AFVs, and your x units are years. So this is giving a rate of change that the number of AFVs is increasing by 35,443.28 AFVs per year. The number of AFVs is increasing by approximately 35443.28 each year. Use the regression line to estimate the number of AFVs in 1997. Round to the nearest whole AFV. Why doesn't your estimate match the actual data? So 1997 is 2 years after 1995. So I'm going to plug a 2 in for X. So I have Y is 35443.28 times 2 plus 216,437.82. And I'm supposed to round this to the nearest whole number. Get a calculator out here. I get 287,324, and that's rounding to the nearest whole number. Why doesn't it match the actual data? So the 1997 number would be right there, which is 290,000, something like that. 290,000. It doesn't match the actual data because this is a model. It's just an estimate, right? The line doesn't touch every actual point on the scatter plot. Use the regression line to predict the number of AFVs in 1988. So that's 7 years before 1995. So I am going to plug in -7. let's see, 35443.28 times -7 plus 216,437.82. I get negative 31,665, rounding to the nearest whole number. But this doesn't make any sense. You can't have a negative number of AFVs on the road. So this is what we call model breakdown, when a model gives an unreasonable prediction. So I would like to estimate now the year in which there are 355,000 AFVs. So that is a y value. So I'm going to put 355,000 in for y, and I'm going to be solving for x. Okay, so some quick arithmetic here. First, I'm going to subtract 216,437.82 from both sides. Then I'm going to divide by 35,443.28. And I get x is approximately 3.9. So it's 3.9 years after 1995. So that would be 1995 plus 3 would be 1998. So almost 1999, at the end of 1998. Okay, in the demo, we saw the slope-intercept form of a line, y equals mx plus b. An equation can also be written in the general, what's called the general form, ax plus by plus c equals 0. And this is helpful when graphing because you can easily find and plot the x and y intercepts. It can also be changed into slope-intercept form just by solving for y. Okay, so here's an equation for a line. I want to find the x and y intercepts. So think about any old line here. When it crosses the y-axis, its x-coordinate is 0, right? 0 comma something. And when it crosses the x-coordinate, it's something comma 0. It's the y-coordinate that's 0. So to find the x-intercept, right, that's right here, you make the y 0. So this is going to be 7x plus 6 times 0 minus 42 equals 0, and I solve for x. So I get 7x equals 42, so x is 6. To find a y-intercept, anytime you're on the y-axis, your x-coordinate is 0. So I'm going to make the x 0 and solve for the y. So it turns out that y is 7. So to plot those, my x and y intercepts would be x is 6, y is 7, and it only takes 2 points to determine a line, so I can then connect those. And if I want to write this in slope-intercept form, I just have to solve for the y. I need to get that by itself. So I start with 7x plus 6y minus 42 equals 0. I'm going to move everything but the 6y over to the right. So I have 6y is negative 7x plus 42. And then I'm going to divide both sides by 6. So I get y is negative 7/6x plus 7. 42 over the 6 gives the 7. Okay, here's a vertical line. Which coordinate, x or y? Oh, sorry. Pick and label any 2 points on the graph of the line. Okay, here's a point, and that's at 3, 5. And here's another point that's at 3, 2. Which coordinate, x or y, do the 2 points have in common? X. And they are both 3. So x equals 3 is the equation of that line. Use the 2 points from A, 3, 5, and 3, 2, to compute the slope. So that's change in y over change in x. 5 minus 2 over 3 minus 3 is 3 over 0, which is undefined. Can't divide by 0. So what must be true about the slope of all vertical lines? Undefined, because you're always going to have the the x coordinates are the same, so when you do the change in x, you get 0 in the denominator. All right, here's a horizontal line. Pick and label any 2 points. Okay, here's -4, -4, and here's 4, -4. Which coordinate do they have in common? Y. Both of them have a y coordinate of -4. That's the equation of the line, y equals -4. Calculate the slope, change in y over change in x. So my y, I have -4 minus -4 over 4 minus -4. So that is 0 over 8, which is 0. So what must be true of the slope of all horizontal lines? 0, because you're always going to have change in y is 0 if the y's are the same. Here's the graphs of 2 parallel lines. Pick 2 points on line A and calculate the slope. All right, so there's a nice point there, and there's a nice point there. So I've got 0, 3, and 1, 5. So my slope is 5 minus 3 over 1 minus 0, which is 2 over 1, or 2. Do the same thing on line B. There's a nice point, 1, 0. And here's a nice point, 2, 2. So my slope is 2 minus 2 over 2 minus 1, which is, oh, sorry, I did that wrong. 2 minus 0 over 2 minus 1, which is 2 over 1, or 2. Conjecture about the slopes of parallel lines, the same, right? Here was my first example, had 2 parallel lines, same slope. We're going to say that that is true of all parallel lines. All right, how about perpendicular lines? Let's look at line A, pick some points here. I've got 0, 2, and another nice point, 2, -1. So my slope is going to be 2 minus -1 over 0 minus 2, 3 over -2. And then for line B, here's a nice point, 6, 3. Another nice point, here's 0, -1. So I have 3 minus -1 over 6 minus 0. That's 4 over 6, or 2/3. So these two, they're not equal, but they are related to each other. The fraction has been flipped over, and one's positive and one's negative. That is always true about the slopes of perpendicular lines. They are opposite, as in one's positive, one's negative. Reciprocals, meaning one is the flipped fraction of the other. So given that information, I want to find an equation for a line that's perpendicular to this line and goes through the point -3, 2. So this line's slope is 3, which means that the slope of my line, the one they're asking me to find an equation for, it has a slope of -1/3, the reciprocal and the opposite of 3. So I know my line looks like -1/3 x plus b. B is the y-intercept. To figure out what b is, I'm going to use this point. I'm going to plug in -3 for x and 2 for y, and I can solve for the b. So I get 2 is 1 plus b. B is 1. It's very tempting to circle b equals 1 and think you're done, but the answer is actually the equation of the line, -1/3 x plus 1, replacing the b with what you just solved for. That is the equation of the line.